4.3 is multiplying and dividing rational expressions. We're going to spend the rest of this chapter working with rational expressions. And when we talk rational expressions, we're talking about these types of expressions that you see in the numerators and the denominators. All expressions, as you look at, I'm hoping you look at and you're like, okay, I see some factoring going to happen. Because that's what we're going to be doing. We're going to be doing a lot of factoring. We're going to brush up a lot on our factoring skills. Today, officially, our job is multiplying and dividing these fractions. Now, before we can multiply and divide them, we're going to go through a little bit just how do we simplify them in general, and that will carry directly into multiplying and dividing. Eventually, after we multiply and divide, a couple of days, we'll add and subtract. After we add and subtract, we'll solve some equations. Okay? So that's kind of where we're headed. So, officially, a rational expression is the quotient of two polynomials. Remember, rational, it's a fraction, right? So when we say quotient of two polynomials is two polynomials divided. The domain is all real numbers except for those where the denominator is equal to 0. And those are what we call the restrictions on the variable. So one of the things we're going to do is we're going to be also looking at any restrictions on the variable. So anything that would make that denominator equal to 0. Okay? A side comment I put in here is that one way I've heard it expressed is that expressions that have plus or minus signs in them are considered married expressions. You can't just cancel a term. You can only cancel a factor. So the idea here that I'm going to lead into is, for instance, that is not a valid move. Okay, you cannot cancel a -4 and a -4 that are being subtracted. Now, if there's an x minus 4 and an x minus 4 is a factor, we can cancel factors. But you can't just cancel a single term that's being added and subtracted with other terms. Okay, so that's where you'll sometimes hear that, okay, these 3 terms in the denominator, these 4 terms in the numerator, they're married together. You can't just cancel single terms, only factors. Okay, so in this first set here, we're going to simplify some expressions. In order to simplify expressions, again, okay, here's an illegal move. No. I can't do x squared cancels with x squared. Okay, I can't cancel a term with a term. So we have to talk factors. So first thing you're going to want to do on every single problem we look at today is, what can we factor? So thoughts on x squared minus 4? Huh? Yeah. X squared minus 4 does factor into 2 parentheses. Does that sound familiar? X squared breaks into x and x, as it always does, right? And if this is x squared minus 4, this is what I would call difference of squares. It's 2 perfect squares being subtracted. So x squared is x times x. What about 4? Square root of 4 is 2. So that's 2 and 2. And how do we multiply to get a minus 4? You need a plus and a minus. Okay? Back to your denominator. X squared plus 3x minus 10. Does it factor? Yeah. Are you visualizing 2 parentheses here? I hope. Okay, this is one that I hope we should be fairly confident in. X squared breaks into x times x. And then what? We need numbers that will multiply to be -10 and add to be 3. What's the easy numbers that multiply to be 10? Okay. 5 times 2 is 10, yes? And 5 minus 2 is 3. We just have to get our signs right. If it multiplies to be a -10, you need one of each, a plus and a minus. If it adds to be +3, what do we know? Bigger numbers positive, smaller numbers negative. Okay, I need you guys confident in these factoring skills. We've reviewed them already. You learned them back in Algebra 1. Okay. Okay, what do you guys notice here? Yeah. we no longer have individual terms. We have factors. We have a factor of x minus 2 on top and a factor of x minus 2 on bottom. That means those factors can cancel. Okay, you cancel a whole factor, not just pieces, but a whole factor. Now on top we still have an x plus 2. On bottom we still have an x plus 5. Those don't cancel. So at this point, you're talking x plus 2 over x plus 5. And in terms of simplifying the expression, you're done right there. Okay, again, that x on top is married to that 2 on top. The x on bottom is married to the 5 on bottom. You can cancel a whole factor, an x plus 2 and an x plus 5, but you can't just cancel the x's. Okay? Now, there was one other piece to the request here. Did you guys catch it? State any restrictions on the variable. So hopefully you left a little bit of room. Not sure, I should have written a little smaller, but that's all right. Restrictions on the variable. Restrictions are what's going to make my denominator equal to 0. Okay, because anything that's going to make my denominator equal to 0 cannot equal x. So in order to find your restrictions, what we're going to do is we're going to take our denominator and we're going to set it equal to 0. Okay, so whenever you talk about finding restrictions, your job is to take the denominator and set it equal to 0. Now, with that in mind, we can go back to the original denominator if you want, x squared plus 3x minus 10. But then we're just going to have to turn around and refactor that. Didn't we already factor it once? We don't need to factor it a second time. So I'm going to encourage you to always take the factored form. Now, when I say take the factored form, before you canceled any factors. So when we factored this, we had x plus 5 and x minus 2. So I'm going to set x plus 5 equal to 0 and x minus 2 equal to 0. So anything that ever was in the denominator, you're setting equal to 0. When we solve those, if it's x plus 5, what's going to happen? Subtract 5 to the other side and you'll get x equals negative 5. In reality, you know what that is though? X cannot equal negative 5 because negative 5 is a place that would make that denominator equal to 0. Same thing here. If it's x minus 2, add the 2 over, you get x equals 2. In reality, that's what? X cannot equal 2. So we have two restrictions on the variable here. Okay, x can be anything we could possibly dream of, except x cannot equal negative 5 or 2, because that would make my denominator 0. If my denominator is 0, that fraction doesn't exist. Okay? Questions there? Okay. Well, let's get some practice in here. I've got some different types of factoring to help us practice, because that's the big thing, is you have to be able to factor a little bit of everything. So, example B. X squared plus 2x plus 1. Thoughts on factoring that one? Does that look like a familiar form? Two parentheses. When it's an x squared, an x term, and a number term, typically think two parentheses. X squared breaks into x and x. What numbers multiply to be 1 and add to be 2? Yeah, my only option for multiplying to be 1 is 1 times 1. If it multiplies to be a positive and adds to be a positive, x plus 1 times x plus 1. What about this denominator? Is it just me or is it warm in here? I'm afraid to turn this down, so I'm afraid I might kill my room today. Although there's also a possibility that this has 0 control and, you know. Okay, what about this denominator? Okay, GCF, right? This does not go straight into two parentheses. It might happen here in a moment, but it doesn't go straight in there because we start with an x cubed, we have an x squared, and an x term. So let's factor out GCF. All terms have an x in common, so we're going to put the x out front. If you factor out that x cubed, divide an x away becomes x squared minus 2x squared, divide an x away becomes 2x minus 3x divided by x is minus 3. Okay. As it stands right now, does anything cancel? No. So, are we done factoring them? No. Okay. Hopefully you realize that denominator has more factoring to go. So my numerator, I'm going to carry down as x plus 1 times x plus 1. My denominator. Okay. One big warning I'm going to give. That x out front, don't lose it. Okay. That's part of my answer. So don't lose that. Now, x squared minus 2x minus 3. I kind of gave it away, but it looks like it should factor into 2 parentheses, doesn't it? X squared is x times x. Well, I need something that multiplies to be 3. The only options for multiplying to be 3 are 1 and 3. How do we multiply to be negative 3 and add to be negative 2? Positive 1, negative 3. Okay. Now, and I can't guarantee it's always going to happen, but noting there's an x plus 1 on top, does it make sense there'd be an x plus 1 on bottom? It does. You don't want to rely on that because that can steer you wrong at times, but it can definitely help as well. Okay, guys, what do we notice? There is 1x plus 1 on bottom, yes? So what cancels on top? 1x plus 1 on top. It's a 1-for-1 deal, not a 2-for-1 deal. So 1x plus 1 on bottom cancels with 1x plus 1 on top. Doesn't matter which one. Anything else cancel? No. We've got x plus 1 that remains on top. Over on bottom, don't lose that x. We have x times x minus 3. Okay. And that's how I would write my final answer there in terms of simplifying. Okay. Now, on Savas, it's not hard to forget because they're going to ask you for the next step, okay? But don't forget to do the restrictions when they ask you for them, okay? So, restrictions. Well, how did I say we were going to do the restrictions? Okay, set your denominator equal to 0. I'm always going to recommend the factored form, but it has to be before you canceled anything. Okay, so in this case, we use that form. Over here, I'm going to say that form there because we want the fully factored form, which means how many things am I saying equal to 0 here? I've got 3 things I'm saying equal to 0, yes? That x matters. So I'm going to say x equal to 0, x plus 1 equal to 0, x minus 3 equal to 0. Okay? And what do we come up with? X equals 0, well, that's just a flat out x cannot equal 0. If it's x plus 1, subtract the 1 over, x cannot equal negative 1. And if it's x minus 3, add the 3 over, and x cannot equal 3. Okay? So you've got a list of 3. Restrictions on the variables, guys. You could have 1, you could have 2, you could have 3, you could have 5. It just depends how many factors you have, what's going on. Okay, when we get into our multiplying and dividing problems, we will very possibly have more than 3. Okay? Okay. I keep thinking, oh, maybe I'll skip some of these, but there we need to talk about GCF. Here, we've got a different type of factoring to talk about that I've got to review with you. So I'm getting a little bit of all the different factorings here. Okay. What about that numerator? X cubed plus 4x squared minus x minus 4. Do you remember how to factor that? Factor by grouping? It is. And hopefully the first thing, did you check, is there GCF in all 4 of these? Check that. There's no GCF in all 4. So when there are 4 terms, factoring by grouping is a good thing to check. And that is exactly what we're going to use here. Okay? With this in mind, on top, think about this in terms of 2 different groups. So if you look at just the first 2 terms, what do my first 2 terms have in common? Okay, x cubed and 4x squared both have an x squared in common, yes? So I'm going to factor out an x squared. And then, what remains? Well, x cubed divided by x squared leaves me with x. 4x squared divided by x squared leaves me with plus 4. Okay. Repeat the process on the second half. What do negative x and minus 4 have in common? Negative x and negative 4, nothing other than they can both divide by a negative 1. Everything can always divide by 1. Because this x is negative, I'm going to say let's divide by a negative 1. And you could just write a negative there. I'm going to write a negative 1 so we don't lose track of what we're doing. When you divide by negative, negative x becomes positive x. Negative 4 becomes positive 4. Okay, that's good news, guys. That's good news because I want that numerator, or I want those parentheses to be the same. Now, I'm going to go ahead. We'll come back to the bottom here in a moment. I have several steps, so I'm trying to conserve room here. But do you remember how factoring by grouping works? It goes into 2 parentheses. 1 parenthesis are your GCFs. What are my GCFs here? X squared minus 1. The other parenthesis is your GCF in terms of we have matching parentheses, yes? So this is x plus 4. Okay? Now, we're going to hold that thought on the top. Let's go get this denominator factored. What about x squared plus 3x minus 4? Does that look like maybe traditional factoring there? X squared is x times x, multiplying to be 4. 1 times 4 or 2 times 2, but the pair that could possibly give me 3 is 1 times 4. If we multiply to be negative 4, I need 1 positive, 1 negative. If we're adding to be positive 3, positive 4, negative 1. Okay, and I'm just going to carry this over here. X minus 1, x plus 4. Now, am I done? Am I ready to cancel? I mean, don't get me wrong, there is a canceling that could be done. However, I'm going to say, you could go ahead and cancel that, but I'm going to say we're not done. What's the piece that we haven't dealt with yet? Yeah, that x squared minus 1 can still factor farther. That's not something that will always happen, but it does here. So we need to go one more factoring step here. Okay? My denominator of x minus 1 and x plus 4 just carries along. My numerator. What about x squared minus 1? Didn't we already factor this form today? This is like our very first problem, x squared minus 4. X squared minus 1. Difference of squares. The square root of x squared is x. The square root of 1 is 1. If it multiplies to be a minus 1, we're talking plus and minus. And what else did we still have on top we can't forget about? Don't lose that x plus 4, yes? There's a lot of pieces here. Keep track of all the pieces. Now, okay, do we have some canceling that happens? Okay, we've got all factoring done now. An x plus 4 on top cancels with an x plus 4 on bottom. An x minus 1 on bottom cancels with an x minus 1 on top. What remains? X plus 1 on top. What remains on bottom? Nothing other than technically a 1, yes? I mean, but do you need, here's the deal. We could say x plus 1 over 1, but do we need the over 1? No, and Savas won't like it, I can guarantee that. Your best answer right here is just x plus 1. Okay? You getting all the factoring under control? That's going to be the key, is you have to be able to factor, guys. Okay, restrictions. Restrictions, are they getting easy? Don't make them harder than what they are. In order to find our restrictions on the variable, set any denominators equal to 0. What am I setting equal to 0? We only had 2, didn't we? Yeah. So x minus 1 equal to 0. X plus 4 equal to 0. So we know that what? X, add the 1 over, x cannot equal 1. Subtract the 4 over, and x cannot equal negative 4. Down below in the next section, we talk about restrictions. You'll see me just list a list of numbers with commas. Okay? You don't necessarily have to list them individually. A list of numbers with commas would be fine. Are we getting the feel for this? Okay. We're going to try and jump into multiplying before we finish today. Now, here's the deal. Are you feeling comfortable with what we're doing here? Because multiplying is no different. It's really no different. It's just a bigger simplifying problem. That's all it really is. Okay? So, as we look at our multiplying section, find the simplified form of each product, and then again, we are going to be stating restrictions. Okay? The difference between what we did up above and what we are doing now. Instead of one fraction, you have two fractions. So instead of a top and a bottom to factor, you have two tops and two bottoms to factor. You just have double the factoring to do. And then it's still going to be canceling. Okay? So don't try and multiply this and then factor. That's disaster waiting to happen. We're still going to keep factoring first. So let's do this. What about x squared minus 16? Does it factor? Third time today, we're going to do difference of squares, right? So you've got that difference of squares. Two parentheses. X squared is x times x. What about 16? The square root of 16 is 4. If it multiplies to be minus 16, that's a plus 4 and minus 4. What about x minus 9? Can't do anything with it, can I? There's no GCF. There's nothing there. So guess what? X minus 9 just cancel or just carries down. Okay. X squared plus X minus 90. Keep factoring. Looks weird, but it's doable. Notice it's of the form, 2 parentheses. X squared breaks into X and X. Multiplying to be negative 90 and adding to be 1. So I need neighboring numbers if they're going to add or subtract to be 1. 9 times 10, yes? Okay. This is going to be 9 times 10. What do we need here? So it multiplies to be negative. It's a positive and negative. If it adds to be 1, bigger number positive. So plus 10 minus 9. And what about x squared plus 14x plus 40? Well, occasionally you might run across something that doesn't factor, but this one factors. X squared is x and x, multiplying to be 40 and adding to be 14. 4 and 10. And this is one, folks, if the numbers aren't coming to you, start going through the list, right? 1 and 40, 2 and 20, 3 doesn't work, 4 and 10, 5 and 8. Keep going, make that, don't be afraid to make that list as opposed to just, I don't know. Okay, so 4 and 10, multiplies to be positive, adds to be positive, there we go. Okay, guys, we factored just like we were up above. Now we're going to cancel just like we were up above. Thoughts on what cancels? X plus 10. 1x plus 10 on top cancels with 1x plus 10 on bottom. What else cancels? 1x plus 4 on bottom cancels with 1x plus 4 on top. Does it matter they're in opposite fractions? No. As long as you're canceling a denominator and a numerator factor, you're good. Okay, we can cancel on one fraction, we can cancel on opposite fractions. And what else? 1x minus 9 on top cancels with 1x minus 9 on bottom. Leaving me with x minus 4. You could say x minus 4 over 1, but really all I need to say is x minus 4. Okay? And not everything will ask for restrictions, but this one still does. How do we find our restrictions again? Yeah, so your denominator factor is equal to 0. Just like up above, anything that was ever in the denominator. If we look at the end result, we have no restrictions because we have no denominator. But we had pieces that were in the denominator originally. So any factor that was ever in the denominator. So what? X minus 9, x plus 4, and x plus 10. What do we know? X cannot equal what? 9, negative 4, and negative 10. Okay? So, make sure you get all of those restrictions. Okay, guys. When we come back tomorrow, we will practice a little more multiplying. I don't know if we'll do all 3 of those or not, but we'll definitely practice some more multiplying. And then we have dividing. Here's the deal, guys. Dividing, we add 1 step. And that's just knowing how to divide fractions, but it's really just multiplying all over again. 4.1, 4.2, if you don't have those done, get those done, okay? 4.3, you can start looking at 4.3. Not going to say you can't, but it won't be due until Thursday.